Hey, geometry students, I think you're going to find that working problems with ratios, proportions, and similarity is really easy. And just like I said, there's really nothing new in this lesson. This is just algebra masquerading as geometry, and it's all stuff you've done before anyway. So this is going to be really straightforward. First thing you're going to do is write a ratio comparing the lengths of three segments. HA, that's this one, 4. AM, that's this one, 9. And MH is 6. And to write a ratio comparing three things, the only way that we can do that is with one of our sloppier forms of ratios. So it's going to be 4 to 9 to 6. And just notice that I had to go in the same order that I named the segments: HA4, AM9, MH6. Next, I'm going to write a ratio comparing AM to LR. Notice I can compare segments that are in different triangles. And that's fine. I have to write it in three ways in simplest form. Well, it's going to be in words, with a colon, and then in a fraction. So let's see, 9 to 27, because AM is mentioned first, I have to start with 9. 9 to 27 is the same as 1 over 3. So I'm going to write 1 to 3 three different ways. Here they are. There's going to be 1 to 3 with a colon, 1, 2, 3 as words, and then the actual mathematically useful way, 1 divided by 3. Next, write a proportion to show that HM compared to PR, that's 6 compared to 18, equals AM 9 compared to LR. So it'll be 6 compared to 18 equals 9 compared to 27. Well, the proportion is just going to be an equivalence statement of two ratios. Easiest way to do that is with fractions. This is what it would look like directly. And then if I wanted to simplify it, see that it simplifies to 1/3 equals 1/3. All right, next, what is the value of x in the proportion 8 over 7 equals x over 21? For this one, we're going to actually use cross multiplication. 8 times 21, if you punch it into a calculator, see it's 168, equals 7 times x. And then if you divide 168 by 7, you find that x equals 24. All right, so really easy to do these proportion ones. You just cross multiply and divide, or you set the product of the extremes equal to the product of the means, and then just use what we've always do in algebra to solve. 3 left. If triangle RST is similar to triangle UVW, find the missing length in UVW. Well, here's what I'm going to do. I'm going to set up a similarity statement for two of my sides. And then I'm going to do the same thing, but with the side that is unknown. So if I say that 8 over 20 is one of my proportionality statements, one of my ratios, my similarity ratios, 8 over 20 equals 10 over x. Notice I started with this triangle. I went to a corresponding side on this triangle. I went back on the other side of the proportion. I went back to this triangle, and then the corresponding side on this triangle, making sure that I have x included. Okay, I can solve this. I'm just going to cross multiply. That becomes 8x equals 200. And then I divide both sides by 8. 200 divided by 8 gives me, there we go, 25. X equals 25. Next, if the polygons MNOP and QRST are similar, it doesn't just have to be triangles. It can be polygons that are similar. What are the measures of angle O and angle R? Angle O has to be the same as angle S because those are corresponding angles. So angle O has to be 62 degrees. Angle R, well, this one's a little bit harder. I need to remember that the interior angles of a quadrilateral have to add up to 360. So 81 plus 95 is 96, 176 plus 62, 170, let's see. So 176 plus 2 is 178, plus 30 is 238. So I do 360 minus 238 will give me 122 as my last angle here. So angle R is going to be 122 degrees. If the polygons A, B, C, D, and E, F, G, H are similar, what are the values of X, Y, and Z? Here, again, I'm going to have to find a proportionality between the small polygon and the large one, I notice that I know the corresponding side to BC. BC is 4, so it's going to be 4 compares to 12 as, and let's see, one of my unknown sides is X, 3 compares to X. I'm also going to use that same constant for how 5 compares to Y, and that same constant for how 9 compares to Z. All right, and then I just cross multiply and divide on all these. It's going to give me 4x equals 36, so x equals 9. Here I have 4y equals 60, so y equals 15. And then lastly, we have, if I cross multiply, 4z equals, and let's see, 12 times 9 is going to be 12 short of 120, so 108. So I know that z has to equal 27. I believe that's 27. Let's see if I'm right here. Yes. And then lastly, Cree uses a 21-foot ladder and a 12-foot ladder while painting the exterior of a house. Each ladder forms the same angle with the ground. If the longer ladder reaches 18 feet up the wall, how high does the other ladder reach? Well, these are going to be similar triangles. I know there's going to be a 90-degree angle. The angle with the ground is the same, and that means that the angle with the house also has to be the same. So let's figure this one out. I can set up a proportionality statement here. So I'm going to say that 21, so the 21-foot ladder reaches 18 feet up the wall. That's going to equal the proportionality or the ratio of 12 to how far it reaches up the wall. We'll make that y. Okay. I'm going to cross multiply here. We're going to find that 21y equals 12 times 18. This is one that would take a little bit to solve, so I'm just going to use a calculator. 12 times 18 divided by 21. And we should get something like 10.29. Let's see if that's right. There we are. To the nearest foot, it's 10 feet up the wall. All right, that's how you use similar figures with ratios and proportions to solve for unknown sides or variables.